Hello students, welcome back to a new mathematics program for grade 8. Today we are going to talk about algebraic terms and algebraic expressions. Well, this video is the second of a series of 3 videos based on this chapter, that is algebraic terms and algebraic expressions. Remember that in the first video you learned how to calculate HCF of algebraic terms. Now in this video, I'm going to show to you how to factorize an algebraic expression. So students, in this program, you're going to learn how to factorize algebraic expressions with single factors. So first of all, let's see what is the meaning of algebraic expressions. Well, an algebraic expression is a mathematical phrase that can contain integers, unknowns, for example x and y, and operators, that is addition, subtraction, multiplication, and division. Let's look at some examples. X plus 1. X plus 1 is an algebraic expression because it contains an integer value, that is 1. It contains an unknown value, that is x, and an operator, that is plus. This one also is an algebraic expression because you can see that there is an integer value, an unknown value, and an operator. Okay, these are some more examples about algebraic expressions. As you can see, in all of these expressions, we do have an integer value, an unknown value, and an operator. Now let's see what is the meaning of factorization of an algebraic expression. Factorization of an algebraic term means putting brackets within an algebraic expression while a common factor is removed outside the bracket. In fact, factorization is the reverse process of expansion. That is, if we have an expression 2 bracket x plus 1, if we expand it, we are going to have 2x plus 2. Remember that you have learned about expanding algebraic terms in grade 7. Now, if we have 2x plus 2, we can revert back to the bracket form, that is 2 bracket x plus 1, through a process called factorization. So if we have 2 bracket x plus 1, through expansion we have 2x plus 2, but through factorization we shall have again 2 bracket x plus 1. Now let's see how to factorize algebraic expressions. First example, factorize ax plus bx. As you can see here, we have a common letter x in both the terms ax and bx. So if we are factorizing this expression, we are going to take this common letter x outside the brackets. So we have ax plus bx equal to x brackets a plus b. This is read as x into a plus b. As I have told you, factorization is the reverse process of expansion. So we can verify our answer here through factorization. So if we expand x into a plus b, we are going to have ax plus bx. So this confirms that factorizing ax plus bx is x into a plus b. Let's take a second example. mx minus nx. Here again we have the letter x common. If we remove x outside the brackets, we're going to have x brackets m minus n. That is x into m minus n. Let's check it. So if we expand x into m minus n, we have x times m is xm or mx, and x times n is nx. This confirms again that the factorization of mx minus nx is x into m minus n. Third example, factorize 4a plus 6x. Here you can see that there is no common letters in 4a and 6x. So we are going to factorize by removing a common factor outside the brackets. The common factor here will be 2 because we can divide 4 and 6 by 2. In fact, we are going to divide by the highest common factor, that is the HCF of this algebraic expression. Okay, here the HCF of this algebraic expression is 2. So we're going to divide these two terms, 4a and 6x, by 2. So we have 2 brackets 2a plus 3x. We can check the answer through expansion. If we expand 2 into 2a plus 3x, we're going to have 4a plus 6x. So whenever we are factorizing an algebraic expression where we do not have common letters, we are going to divide by the HCF of the two integer values. Let's have an example again where we have 5x minus 15y. Here the common factor is 5. We can divide 5x and 15y by 5. So we have 5 into x minus 3y. Again, we can check through expansion. Presence of negative sign. We're going to continue with factorization of algebraic terms, but now we're going to have a negative sign in front of the brackets. Factorize minus ax plus bx. We do have a common letter here, x. So through factorization, we're going to remove this x outside the brackets. But we also have a negative sign at the beginning. So through factorization, we have minus x outside the brackets. And since we have a negative sign in front of the bracket, the sign inside the bracket changes. Can you tell me why? It is because through factorization, we are going to divide the two terms by a common factor. The common factor here is minus x. Now if we divide minus ax by minus x, we have positive a, because the negative sign is outside the bracket. But if we divide positive bx by minus x, positive divided by negative is negative. So inside the bracket, we have minus b. We can check this through expansion. Remember in grade 7, while expanding algebraic expressions, you learn that whenever we do have a negative sign outside the bracket, through expansion, the sign inside the bracket changes. Simply because we are multiplying minus x by plus a, so we have minus ax. Now if we multiply minus x by minus b, we have positive bx, because negative multiplied by negative is positive. This confirms our answer in factorization. That is, factorizing minus ax plus bx is minus x into a minus b. Let's take another example. Here again, the letter x is common. Since we have a negative sign in front of the bracket, while removing minus x outside the brackets, the sign inside the bracket changes. Again, we can verify the answer through expansion. And here, while multiplying minus x by m, we have minus mx, and multiplying minus x by positive n, we have minus nx. That is why, through factorization, the sign has changed inside the bracket. Another example, here the common factor is 2, but since we have a negative in front, we're going to take minus 2 outside the bracket. So minus 4a divided by minus 2 is 2a, and positive 6x divided by minus 2 is minus 3x. So factorizing minus 4a plus 6x is minus 2 into 2a minus 3x. Through expansion, minus 2 times 2a is minus 4a, and minus 2 times minus 3x is positive 6x. As you can see, whenever you are factorizing an algebraic term, you can always check your answer through expansion. Let's have a look at some more examples on factorization. Factorize a squared minus 2a. Remember that you learned that a squared is same as a times a. So we can write a squared minus 2a as a times a minus 2a. So it's easier to see the common factor. The common factor here is a. So we have a brackets a minus 2. That is, factorizing a squared minus 2a is a brackets a minus 2. X squared minus 2x. X squared is x times x. Then we have minus 2x. The common factor here is x. So the answer is x into x minus 2. If you have a negative sign, as I've told you, the sign inside the bracket will change. So while removing m outside the bracket, with the negative sign outside, the sign inside the bracket changes. Again, because we are dividing these two terms by minus m. So minus m squared divided by minus m is m, and minus 3m divided by minus m is positive 3. So factorizing minus m squared minus 3m is same as minus m into m plus 3. Minus 3x squared minus 6x. What can you see here? The letter x is common, but we do have a common factor of 3 and 6, which is, of course, 3. With the negative sign and the x as common factors, we have minus 3x into x plus 2. Why? Because dividing minus 3x squared by minus 3x, we have x, and dividing minus 6x by minus 3x, we have positive 2. So factorizing minus 3x squared minus 6x, we have minus 3x into x plus 2. Now I'm giving you some exercises for practice. Factorize the following. Again, if you are having any difficulties in finding the solutions of these numbers, you can seek the help of your parents or teachers. Students, if you want to have some more information on this chapter, you can consult these websites. So students, in this video, you have learned how to factorize algebraic expressions with a single factor. So students, this program ends here. Remember that this video is the second part of a series of 3 videos based on the chapter Algebraic Terms and Algebraic Expressions. You have learned how to find the HCF of algebraic terms in the first video. In this second video, you have learned how to factorize algebraic expressions with a single factor as common factor. In the last video, you're going to learn how to factorize algebraic expressions with common factors. See you soon. Goodbye.